sklearn is the framework which handles data structures, math, linear algebra, calculus, and statistics, everything, isn't it? And then what would be the maximum learning rate we can pass? 0.012, 0.012, 0.012, 0.08. All right, we can pass up to this. So we done the difference between gradient descent and also 2 seconds. Let me cut them up and I move here. So this is, I'll take this to wrap text. Okay. So this is gradient descent and this we called stochastic gradient descent. Okay. And then we have batch gradient descent. One moment. Okay. So this part we done. And then, so step count should be very minimum or maximum? The step count is minimum to reach global minima. All right. We SGD, GD, we covered, guys. Okay. What is feature scaling technique? The feature scaling technique. What are the techniques, guys? We have normalization. Also, we this call as normal scalar. And what we other concepts we call is min-max scalar. What is range, guys? 0 to 1, isn't it? What is other technique? Standardizations. We call standard scalar. What is the range for it? -3 to 3. This is also we call the G-score or not? Okay, so this part we covered. We also done practical for this and I shared to you for work. All right. Yeah. So this is what we done. Let's copy and paste here. So today is 16th. So how many of them attended yesterday's workshop? 7:30 p.m. batch 1. You? Okay, Ramana, I think you had some issue. Are you solve అయిందా అది yesterday's file? Pranay?
Yes, sir. అయింది సార్.
Okay. ఏం ఇష్యూ ఉండే? What was issue?
అంటే ఇన్స్టాలేషన్ కరెక్ట్గా అవ్వలేదు సార్.
Okay, okay,
ఫస్ట్ ఫోల్డర్ క్రియేట్ చేశాక మనం అన్ని ఇన్స్టాల్ చేసాం కదా సార్.
okay. All right, no problem. Okay, so online team, no one. Okay, Pranay, you done? Okay, okay, Ratna, you done, right? All right, so only 2 member. Offline team, 1. Chesha, వచ్చింది output? You got your outputs? Good. Excellent. So it's a good session or not? How the agents. So we have multiple agents, guys. We will work with LangChain agents. We work with Creo AI. So we'll work with LangGraph, all those things. So why you others not? It was good session. Pranay, please comment it as well. So the one who watched, please comments, guys. All right, to the video. What is today's date? 16th. 16th. Okay. Yeah. So the students or the learner who didn't watch the workshop, it's your wish. It is absolutely your wish. You can do it or not. It depends on you. But if you understand, so we work two times, guys. I mean, same Gen AI session, you can focus on 2 times. Anyway. Okay. So today, what sessions I have for you is 16th. Bias variance we done. Okay, scaling techniques we covered. Let's understand the agenda today is regularization technique. Okay, and also we work practical for the regularizations. And may I know when did I explain this? Why to use regularization technique? Why to use regularization technique? Anyone? Why to use regulation technique? Excuse me, focus the class. Why to use regulation technique? To prevent overfitting. We have overfitting or not? What is overfitting? Train the model with more attributes. So what is the techniques to reduce overfitting? The first one is PCA, then regularization, then ensemble. Anything else, guys? You forgot. Cross validations, very good. Cross validations, drop out the neuron and dropouts. We done all those things or not? So today we understand a regularization technique. This technique, if we reduce overfitting, the model accuracy will increase or not? When the model accuracy increase, we deploy the model. Okay, then have a look at it. So we go ahead and do one by one. First thing, regularization. What exactly mean by a regularization technique? We will understand, and we do practical for this today. And I want you to do this. I'll share the data so that you can work. Online team, let's go ahead and understand. The first one, Lasso Rich. So regulation technique is divided into three parts. The first one is ridge regularization or ridge regressions. We call L2. Lasso regularizations or lasso regressions, or we called as L1. Then elastic net regularization, which is combination of L1 plus L2. So these techniques we implement everywhere. We implement in machine learning and deep learning as well, in computer vision as well, guys. So we done all the platform, this regression technique. Understand, team? What is overfitting? Train the model with more attribute. How to reduce overfitting? We apply the regularizations like ridge, lasso, and elastic net. Okay. So can we go ahead and understand one by one? Ridge, online team, everybody joined? Online team, everybody joined? Okay. So I do see many of 7:30 p.m. didn't attend yesterday's workshop. Reduce the impact. Yeah. All right. Just go ahead and understand one by one and we cover this. And then we go to the practical. Let me finish the theory and then I'll share the data set. Then we can start. Okay, ridge. Let's have a look at it. Assume I have one equation. If you see this equation, one moment, 0.9, okay, 1.2 and 20x2. If you see this one, 0.9, 1.2x1, 20x2, 39x3. Can you please tell me which independent variable is highest impact to dependent variable? 39? X2, guys, isn't it? X2 or X3? X3. 39 is highest impact to the dependent variable. So I mean the coefficient is very high over here or not? The coefficient is very high. So what is the next variable? 20x2 means 20 is coefficient of x2. So similarly, in our model, when we have multiple variables, every variables had some coefficient. Understand? So remember, whenever we trained the model with high coefficient, then there is a chances there will be overfitting problem comes up. There will be overfitting problem comes here. So the two things, the first thing, how to reduce high coefficient to low coefficient, then we don't get overfitting or not. If I reduce my coefficient to high to low, so what happened? The overfitting will reduce, guys. Team, are we clear? Offline team and online team. So here the question is how to reduce. So there is a technique called regularization. There is a technique called regularization technique. What exactly regularization, a regularization technique, what exactly it will done? It reduce the high coefficient to low coefficient and fit the model. Team, are we clear or don't understand? Are you able to understand? Very simple. I have some equation. In this equation, we have highest coefficients of independent variable. And because of that, what happened? So the overfitting problem comes up. So we reduce the high coefficient. So by apply ridge regressions, look at the formula, loss function plus penalty. Loss functions plus penalty. The moment when you apply the ridge regressions equations to this data set, to this equation, 1.2 has scaled down to 0.7, 20 has scaled down to 2, and 39 has scaled down to 5. Now, don't you think we don't have high coefficient now? Do we have high coefficient now, guys? No, that means what exactly ridge technique will, ridge is L1 or L2? It's L2. L2 regularization technique, it reduce the high coefficient to low coefficient for independent variable, and then we fit the model to reduce overfitting problem. Guys, how many of them clear? Offline team? Online team, how many of them understand? Clear? Very good, Aparna, Sushma, Vamshi. What about rest of them, team? Are you there? Or today is Monday, it's board day. Okay, I will do practical for this. Understand this one. So in interview, please explain the same thing, whatever we explain, guys. L2 is ridge regression or ridge regularization. It reduce the dimension, or you can say, or scale down the high coefficient of independent variable, reduce to low coefficient, and fit the model to reduce overfitting problem. Guys, are you clear? Practically, the sklearn library itself take care of each and every coefficient values. Are we clear? Okay. Now this is what ridge. You see the formula? Loss function plus penalty. What is meant by penalty? I'll explain this W terms in neural network well. Right now you understand W square is W1 square, W square, W3 square, and continue, guys. And wait, just have this one. This is called ridge. Let's go back to the lasso. If you see the formula, do you see any difference in the formula, guys? Ridge and lasso? What is the differences we got? What is the Sri? Are you school kid? Difficulty to understand? Very simple x1 coefficient, 20 x coefficients, guys. It reduce. Then can you attend the classes offline? Ping me, I'll talk. See, that's the problem. You never understand. How much slowly I'll explain, guys? You don't know what exactly. Very simple. In the equation, y 0.9 plus 1.2 x1 plus, okay, let's do this here. 20x1 plus 35x2, which is highest coefficient. 35 is x2. By apply ridge technique, so what happened? Constant is always constant. Plus 20 will reduce to 2x1 and 35 will reduce to 5x2. This technique is called ridge. How come you don't understand the simple things, man? Sri, I don't understand. Who will give you a job? Who will give you a job? Is this very hard topic which I'm explaining today? Online team, please response. Is this very hard, guys? Now, Sri, can you respond, please? Very much clear. And what? This is simple concepts. If you can't, how you become a data scientist, man? Which company give you 1 lakh per month? No, see, change attitude. Sorry to say this. Don't be habit of understand spoon feeding. I know offline team, everybody hear the classes, but nobody understand the concepts. Anyway, so this is called ridge. Can we in ridge, in the equation, we have square function. We have a square functions in the equation, means in the formula. Can we go to lasso? What is meant by lasso does? Just go here and go to the lasso. In the equations, do we have a square? Do we have a square? No. When we don't have a square, what happened? The 39 will change to 5. 20 will scale down to 0. 1.2 and scale down to 0. Constant is a constant or not? That means if I solve this equation, 0.9 plus 0 plus 0 plus 5x3, are we eliminate two attribute or not? Are we eliminate two attributes? The eliminate true attribute means, can I say feature selection? Feature elimination? So what are the feature elimination technique? RF is one technique, recursive feature elimination one technique, and lasso also act as one technique, guys. Remember. Now in this, go to my notes and understand. Let's apply, copy, and same here. By apply L1, what happened? Y equal to 0.9 plus 0x1 plus, or you can say 35x2 and 54x3, and now 0x2 plus 3x3. So the final equation is 0.9 plus 3x3. Don't you think the moment when we apply lasso, what happened? Overfitting is reduced or not? We trained with 3 attributes. Now we're going to train with one attribute itself. So always remember the feature elimination and feature selection technique equal to the first, how do we select a right attribute? Business understanding, first point. The second one, RFE, recursive feature elimination. The third step is lasso regressions. The another attribute is correlation. Using correlations, are you find out the right attribute or not? So these many concepts we have. So very simple. What is meant by lasso and ridge? Let me tell you, L1 and L2 is both regularization technique to reduce or scale down high coef to low coef to build best fit model. To build best fit model. Are we clear? But in L1, we reduce coef to 0. But in L2, we reduce coef to not 0. Clear? What is overfitting? We already done that. Now next one, elastic net. Elastic net is nothing but its combination of L1 plus L2. Just if you go to the code now, elastic net, just open the slides. Ridge, square we have, lasso, we don't have a square. Now elastic net, loss plus both alpha and alpha square. Guys, I hope you understood this one. Elastic net. So now what happened? These concept, entire machine learning journey, I'll use this. When we build SVM model, I will show you how these models are used in upcoming classes. Now, can we go ahead to the practical now for the same project, for the same content, same project? Let's understand, guys. The first one. Why many offline students are absent today? So please attend, guys. Okay. I will share one data set, task 22. Car MPG, miles per gallon. Just copy and you can go here. I know. Yeah, proof. That's true. Okay, team. Let's work on L1 and L2. Okay. So I really appreciate some of the students are create a fantastic. Okay. Open a new file, open a new notebook, everyone. Online team and offline team. So the lasso ridge, whatever we understand today theory, let's implement in practical. Let's implement in practical. So which one will reduce to 0? L1 or L2? L1. L2 is not reduced to 0. Okay. Now, can you please write this pandas, numpy, seaborn, matplotlib, sklearn import pre-processing, and polynomial regressions we haven't covered, so you can leave it. So today we work on sklearn.linear model, linear model, non-linear model. What is the non-linear model? The degrees are 1 means linear model. Non-linear model means linear regressions, lasso ridge. Are we learn lasso ridge today or not? So please mention all these libraries and let me know once you complete. Let me know once you complete. Shall we do practical? You don't want, guys. Okay. So then theory concepts both should clear. Got the file? Okay. Yeah, you can work on Jupyter. So far, we understand simple linear regressions algorithms we completed. Multiple linear regressions model we completed. Gradient descent, stochastic gradient descent, batch gradient descent we completed. Now what is the next one we following? Lasso ridge. Today we'll complete. And after that, tomorrow we build SVR model, KNN model. Two algorithms we build in Spider. Okay, tomorrow we build that. All right, team. So every day, one algorithms I'll finish. Try that. Sri, are you working? Okay, VS Code. Okay, your wish. You can work Apurv. It's up to you. Team, everybody, are you guys working or not? Online team. Okay. Yes. Arnav. Okay. Yes, in Spider. Okay, no problem. No problem. I'm telling you, right, in last class, I have only 30 people. Only 30. MPG, very good. The one who said MPG, okay, then it is a dependent variable. Okay, clear? See every MPG mileage and cylindrical dispersion HP, accelerator, year of manufacture, origin, car type. Very simple. Very simple data sets. Now, car name. We have these car names, right? Chevrolet, and there's a multiple. Every Ford is American company, and Chevrolet. So Tata is Indian brand. So every European cars, Indian cars. We have these cars from multiple countries. Okay. Yep. Now, data drop car name XS1. I dropped it because everything has numerical. This is categorical data. I drop X's and replace one refers to America. So if I go to the data set, just go to my, where is my folder? Just 1 second. Project, open it. Okay. Do you see origin? If you filter one, this is all belongs to American cars, guys, manufacturer. Understand? And if I go to two, just go ahead to Audi. Which car? Europeans or not? Volkswagen, Audi, BMW. This is all origin. So this one is referred to which one? Toyota. So origin. Manufacturer country. So if I go to the code, what I done, one refers to America, European and Asian car brands. So replace. Now pd.get dummies origin, and once you try that, so from the data sets, I don't want it because when I know which origin manufacturer, it's not use of this variable, guys. Team, are you clear or not? So can you please write this code and you can see car type and we create a 3 variable. This car is America. So this America, rest of them got 00. Guys, are you getting my point? So can you please do this? And we can apply a lambda function. Do you see we have a question mark in the data set? Where exactly I have a question mark? Just go to the car type, and here I think you have some question mark as well. Control F. Do I have somewhere? Wait. Can you please 30th line? Okay. Which one, guys? 34? 34. Yeah. Do you see HP? We have a question mark or not? Okay. Now, can you please write this code? You understand or not this code? From the data set, data is the variable which store entire data set. from the data sets, we drop car name. X is 1 means column or row? X is 1 means column or row? What happened? X is 1 means column. X is 0 means row. Now, data origin. What is the data origin? This is data origin or not? Origin attribute. Replace 1 to America, 2 to Europe and Asia. That means we created 3 attributes over here. And check this now. And data replace question mark to np.none. Because when you have a question mark, you cannot implement strategy, guys. Mean strategy, median strategy, or mode strategy. Now, what is lambda function? Fill NA means fill the value with median. You can also fill the value with mean. What is lambda? Lambda is an anonymous function where multiple functions or multiple operations, you can write it in one code, one line. That's called lambda. I will understand in functions. I'll explain how the filter works, how the map works in lambda, how the reduce functions works in lambda, guys. So that means please apply the 1, 2, 3, 4, 5 lines of code. Are you able to understand everything or not? Okay. You should get this output. So data.head now. Can you please check data.head? Do one thing. I'll copy it and I will post in the, try this. Lambda functions I'll explain later. Don't worry, but in the project you can use it. Venu, understand? Done. Very good, Ratish. Now head function. Once you're done, model building, guys. To model building, how many attributes required? 2 attributes required. So how to get a coefficient? When I build a model, then only I get my coefficient or not? lr.coef. When we build the model, then only we get a coefficient. Guys, are you done this one? df.head. Check. Are we create 3 variables like that or not? Created. Very good. Now we have to predict the MPG model building. Here we'd like to scale the data column. Now I want to divide X and Y from the data set. X means from the data sets, if I remove MPG, then rest of things is independent variable or not? Try that now. Now X equal to X is 1, and this is very simple way you can try that. Okay, one moment. This one completed. I shared this file. I shared the code in the classroom. Complete or not? This one. Okay. Now try that. So what we done? We split the data into independent and dependent. See, you have normalization, standardizations. Can you please use today pre-processing library and scale X means, do you see each and every attribute has not an equal scale? Are you able to understand this, guys? So that's why we need to make our file to equal scale. Pre-processing dot scale X, pre-processing dot scale Y. Can you write this code? And you will verify X underscore S and Y underscore S. Please check that. Okay, wait. One second. Done this, guys? Now, okay, here what happened? You get like ones or zeros, guys? I think I want to pass d type equal to int. Is it? Get dummies, I think. D type. Oops. Key error. I think origin. Try that. So if I remove the D type, so this would be okay. Oh, I haven't done this. Now try that. So true, false, none. Okay, so are you use D type, guys? It's not working? Int. It's supposed to work. Yes, it is working. Yes, sir. But strange. I'll go here. Now it's working. Okay. See, it's working for me now. So I mean, you have to execute this code and then you can check this. Team, are you complete this one? Okay, check this code. File, save all. Why you guys see? And now have a look at it. So now we read the data set, guys. Everyone, listen to me. You read the data set. Once you read the data set, you have a look at this code. In the code, you please enter d type equal to integer. If I remove this argument, you get true, false, false, all those things you'll get. Now, the moment when you say d type integer, I mean, all those things is done. Guys, clear? Next one. Now, I apply a scaling now, guys. Can you please follow this? X underscore scale. Do you see all the variable has my questions? Why scaling is required? When I build machine learning model, I make my all attribute in equal scale, isn't it? Yes or no, guys? So if you see the scaling here, 8 will change to 1.49 and 307 also scale to 1 and 3504 also scale to 0.63. Guys, are you done this? It will get -3 to 3 range. You won't get any range out of that -3 to 3. So then same way, now what do you do? Y underscore S, check this MPG, it's a dependent variable or not? I told you without scaling, if you build the model, the accuracy not works. So that's the reason you can add and you can X underscore scale. Please show 18 and 19, 17th, 18th. Can you please done this now, guys, quick? Understanding what is meant by scaling, everyone. Every machine learning model has to scale. And what is the feature scaling technique? Normalization and standardization. So here we apply processing, standard scalar process. Sir, car name X1, replace. Okay, which code it's not working? This one, guys. I will copy and just go here and you can enter D type and execute and post. It will work now. Check this. Sorry. Ask them to run. Guys, can you run all the cell? It will work. Exactly. So Apurv, can you car name not found? Sahite, check properly, guys. Check, run all the code from beginning and see your attribute. Very simple way I'm explaining, guys.